I saw that a number of us struggled with these two questions from yesterday's classwork, so I wanted to go over them together. The first question is number 51. We have the square root of 3d squared divided by 5. The first thing I'm going to do is I'm going to split this up using the quotient property and give the numerator and the denominator their own square roots. So let's rewrite this as the square root of 3d squared over the square root of 5. Now we can approach this in two different ways. We can first fix the denominator because this is a radical in the denominator that's not allowed, which means that it's not rational. We would have to rationalize the denominator. I also see that there is a perfect square. This d squared is in the numerator, making it a perfect square that needs to come out of the radical. So it doesn't matter what order you do it in. Let's rationalize the denominator first here in this one. So to rationalize the denominator, I'm going to take the radical in the denominator and I'm going to multiply it by the numerator and the denominator. So let's multiply by the square root of 5 over the square root of 5. Now we're going to multiply across the top and across the bottom. So this becomes the square root of, 15d squared over the square root of 25. Okay, so now let's take out our perfect squares. D squared is a perfect square, so I'm going to put that in its own square root, times the square root of 15 is not a perfect square, so it's going to go in its own square root, over the square root of 25, and 25 is a perfect square. So let's take the square root of the two perfect squares. The square root of d squared is d, and then square root of 15 stays the same, over the square root of 25 is 5, and that gives us our final answer, d times the square root of 15 divided by 5. Let's look at number 63. This was a real world problem, and they were talking about the current, electrical current. The formula is I equals the square root of P divided by R. In the problem, they gave us that P equals 147 and R equals 5. Let's plug these two numbers into our formula. So we're going to have I equals the square root of 147 divided by 5. We're going to start off the same way and separate these numbers, put them in their own square root symbols. So we'll have the square root of 147 divided by the square root of 5. Our next step is to rationalize the denominator. So to rationalize the denominator, I'm going to take the square root of 5 and I'm going to multiply it by the numerator and the denominator, square root of 5 over square root of 5. Let's multiply across the top and across the bottom. So if I multiply 147 and 5, I get the square root of 735. And then in the bottom, I get the square root of 25. Now, I see that 25 is a perfect square, so I can square root it. 735 is not, but it does have a perfect square factor. So let's find the biggest perfect square that goes into 735. And that number is actually 49. 49 goes into 735 15 times. So I'm going to separate 735 to be the square root of 49 times the square root of 15. And this is still over the square root of 25. Now we're going to take the square root of the perfect squares. So the square root of 49 is 7, and the square root of 15 stays, over the square root of 25 is 5. Now if we wanted to leave our answer like that, we could, but in the question it wanted us to round to the nearest hundredth. So we can also say that this is approximately 5.42 amps.